First, a brief introduction. I've been doing professional software development for over 20 years. I always was close to code and still am, and I must say I love it. Almost 2 years ago, however, I joined the dark side. I became a platform engineer and then lead SRE engineer at Form3. And I must say, I do enjoy this change. So basically at Form3, we provide a payment as a platform model for financial institutions to make integration across multiple payment schemes easier and faster. We are a very technology-oriented company, cloud-based. We work on our new platform, which is multi-cloud across AWS, GCP, and Azure. Obviously, we use microservice architecture, and Kubernetes is our daily tool. As we work with payments, so we care about security as well. So today, some 101 course in Kubernetes hacking. First, a very brief introduction to Kubernetes architecture for all of us to be on the same page. Then some also very brief introduction to OWASP Kubernetes top 10 risks. And then the fun part, so 2 demos when I try to hijack your accounts with Kubernetes. So short introduction to Kubernetes architecture. So for sure, most of you know that Kubernetes consists of 2 main components, control plane and worker nodes. Control plane, or also known as master node, is basically the place with API server which controls and manages worker nodes. As a developer, you usually connect to API server via kubectl because API server exposes a REST API. You can connect, you can create new resources, see resources, or update them. On the other hand, worker nodes are the place where the actual fun happens and the actual work happens. So worker nodes basically run your application workloads. Each worker node has kubelet. Kubelet basically is sort of a proxy between API server and worker nodes. It translates API server requests to what should happen on a given node. So basically, the main responsibility of a kubelet is to create and execute new pods. So that's going to be very important that kubelet also exposes a REST API. Similar to API server, you have some sort of REST API on kubelet side. However, usually it's hidden and not directly exposed to developers. That's only for the purposes of API server and management of worker nodes. So now let's take a look at some OWASP Kubernetes top 10 security risks. Basically, I think that most of you are familiar with OWASP. OWASP stands for Open Web Application Security Project. Basically, that's a non-for-profit organization which aims at increasing security awareness among developers. So it all started with web application, but then they extended their scope to other technologies like mobile, cloud as well. So, and most recent, and most likely you also know that they publish every couple of years, they publish top 10 security risks for web applications. So last year, for the first time, they prepared this top 10 security risk list for Kubernetes. And here you see the list. Number one on the list is insecure workload configuration. So basically how we configure and run our pods, ultimately our pods. So however you configure it, in the end, it's gonna be some sort of a pod or a service. So here we need to be careful to not run pods as root, avoid any privileged pods, avoid any writable file systems, and that kind of stuff. Number two on the list is supply chain vulnerabilities. So basically, when you want to deploy a Kubernetes workload, usually you need some Docker image, you need to build, you need to package your application, you need to create an image, and then you need to deploy it. And each and every step of this process, a hacker can hijack the step and can somehow sneak a vulnerable software that could be exploited in actual runtime. So that's also important to protect our CI/CD pipelines or any other process we create and package our applications. Number three, I think is very important in Kubernetes world, obviously. However, it tackles also other kind of applications, overly permissive configurations. So in case of Kubernetes, it refers to RBAC, but you obviously are aware that we need to keep the principle of least privilege, so configure our applications or our systems in general to have the least privilege that are required to run a given application. Number four is about lack of centralized policy enforcement. So if you are talking about, for example, avoiding any privileged pods, so it's not only on us developers or DevOps to prepare correct YAML files. It's also about automation. So we need some sort of policy enforcement on Kubernetes level to reject, for example, deployment pods with too wide configurations. Number five is important in Kubernetes, but it's also a general rule that we should log and monitor any events, especially security events in our applications. Number six, broken authentication mechanisms. That's also very risky and one of top 10 for web applications, for example. So yes, we need to pay attention how we configure our authentication mechanism in our Kubernetes clusters. Number seven is very specific to Kubernetes, missing network segmentation controls. Because with Kubernetes, we have this flat networking model. So every pod can connect to any other pod in a given cluster. So considering that we can run many different applications in a single cluster, then we need to take care and provide some sort of segmentation between those applications just to avoid any cross connections between applications. Secrets management failure, that's a very popular vulnerability. From time to time, we have those news where we learn that some big organization leaked some secrets in a public repo, for example. So here, in terms of Kubernetes, we also need to keep any authentication tokens or any secrets like Kubernetes secrets safe and secure. Number 9, misconfigured cluster components. Kubernetes is a very complex software, so it could be like easily misconfigured, or any typical component we run on Kubernetes could be easily misconfigured, which eventually could lead to compromise of entire cluster or at least some applications. So it's number 9 and number 10 are connected, misconfigured cluster components, and number on one side. On the other side, number 10 is outdated and vulnerable Kubernetes components. So as with every software, it happens that we have some sort of bugs in Kubernetes on some regular workload we run in Kubernetes. So it's important to patch our versions and update to newest versions to avoid any security vulnerabilities. So that was like very brief introduction to theoretical introduction to Kubernetes top 10 security risks. And now I would like you to feel the danger. So I'm gonna demo some of those vulnerabilities and show you how a hacker can hijack your accounts. I have a demo application prepared for you. You can scan QR code, or you can just go to this link, that's form3.yonlabs.com https. I've also posted this one on my Twitter account, which is twitter.com yonlabs. YONLABS. I would like to ask you to register a new account. So each account has a secret data. I would like you to log in and to wait to be hacked, because my objective is gonna be to hack your accounts and learn your secrets. So once you go to the application, you can register a new user. So please register new users. I've already registered mine. I will wait for some users to be registered. However, just in case, I have also a victim user, so I can use one of my extra account to show you how hijacking actually looks like. Oh, I see the first one from Germany. Nice to see you and hello. So I'll be waiting for you. And in the meantime, I will also start preparing my hacking tools. So basically, the application obviously is deployed into a Kubernetes cluster. That's a self-managed Kubernetes cluster, which has been installed on AWS EC2 instance. I haven't made this instance public. Why? Because I didn't want all those swarms and scanners to hijack my cluster. So because I know that there is some vulnerabilities over there. So that's why I've put it in a private subnet. And in the same subnet, I have my evil server, the evil server from which I will do all the hacking today. So I will log into my evil server. And okay, so I know that I'm in the same subnet as my Kubernetes cluster, my target victim. So the first step which hackers usually do is some sort of port scanning. Here I'm targeting Kubernetes, so instead of any nmap tool to scan the ports, I will use a very specific tool, kubelet CTL. That's the one. With kubelet CTL, kubectl is a very similar tool to the kubectl. kubectl or kubectl, you know that as a developers you can connect to API server via kubectl. With kubectl, you can connect to kubelets. Uh, this is a small tool prepared by CyberArk, that's a security company. So just to make it easier to interact with kubelet REST API. And what we are interested in at first is the scan command. So basically it scans for nodes with opened kubelet API. So let's scan. We provide a CIDR range which we want to scan. At the moment, I will keep the CIDR range quite small. And oops, that's not the command. That should be kubelet CTL. Let me fix the mistake and let's start scanning. So you see that kubelet CTL found a node with open kubelet API. Let's export this AIP just to avoid repeating it manually. So what does it mean that the kubelet API is open? So basically, we can connect to it, for example, with curl. We have page not found because we need to provide some endpoints. So let's see, for example, pods running on a given node. We have a lot of pods. Let's format it, or even let's see the name of the pods. That should work. So we see the name of the pod. So you see that we can basically connect to kubelet without any extra authentication and authorization, and we can do whatever kubelet API allows us to. So again, even instead of using curl, it's much easier to use kubelet CTL. So let's switch to kubelet CTL. And now we still use scan command because we want to see which of those pods allows for command execution. So we are scanning for remote code execution, and we are scanning on our server. So we have the list of all pods running in a given node, and we see that, for example, this Redis pod allows for execution of a command inside a given pod. The same case for RCE, hello RCE. And also we have some demo application that's most likely our target. One more thing to notice is take a look here. For example, this is like a default deployment of Calico. Calico is a CNI plugin. So this allows for command execution as well. So what does it mean, command execution? That basically we can execute any command inside a given pod. So let's try it. So again, let's use this kubelet CPL. This time with run command. We want only who am I, a simple command to be executed, and we want to execute it in this maybe server, demo server pod. That's a namespace backend and container demo, and then server, our server. Okay, we are root in this pod. That's another like some sort of weak configuration which could lead to some sort of exploitation while connected with some other vulnerabilities as well. So basically now when we know that we can run any command, usually the next step in hacking, if we know that we can run a command, is like to establish a reverse shell for more comfortable work. What does it mean, reverse shell? So basically when you want to access a remote server, a remote machine, you usually log in and you are given a shell. So the environment when you can execute your commands. Reverse shell is that similar way a hacker is given a shell, but instead of logging in, so connecting from a client to a server machine, we will establish a reverse shell from the server connecting to a client machine. This way, we can bypass this authentication logging in step. So here we can execute any command. To establish a reverse shell, we usually use netcat. That's like the most popular. So I was telling you that to establish a reverse shell, a server needs to connect to a client. So first, we need to run something on our client to listen for a connection. So I will log in to my evil server. Oops, sorry. Once again. And now I'm listening on port 4444. So now I want to establish a reverse shell. So basically I want to run a command inside my pod, but instead of who am I want to run nc connecting to my evil server, and here I need to take a look what public IP I have configured here, and my public IP is here. That's the public IP of the evil server. I'm connecting on this port 4444, and I want to expose a shell. So let's see. Here in another window, you see that connection was received. So here I should have a shell. Let's try ls. Yes, I have a shell. Uh, this is not like a fully interactive shell. It has some problems with stream redirection, so I don't have all those features as with rich shell. You log into a regular server. However, sometimes you can work around that and configure some TTY eco options, etc. But it depends on your local environment and as well as a shell which is available on the server. Here we have only this simple bin sh shell, so not many options available. However, we can do and see what's available here. So yes, we can look around, see what's configured, look for some tokens, again, some sort of reconnaissance from the hacker's point of view. Usually also we check mounts to see if, for example, a host file system is available or whether or not pod is deployed in a privileged mode. Unfortunately, here we don't see a host file system or any indication of deployment in a privileged mode. But we are root. We are root. So we can do for sure a lot of things. Let's take a look at netstat. Netstat, what's available and what's listening on the spot. So we have this application listening on 1990 port. So most likely that's the demo server application. So it would be good to see if what the traffic is going to this application, maybe something interesting. So for this, to snip the traffic, we need TCP dump. We can take a look if TCP dump is available. Unfortunately not, but we are root. Let's see if that's writable file system. Yes, it's writable file system. So now if we are root, maybe we can install some extra packages. So let's try APK and add TCP dump. So now we have a TCP dump available. And now I will take a look at my cheat sheet just to see the actual command I want to run to see HTTP request and responses going in and out from this server. So now I'm listening and sniffing the traffic. So kind request to you if you could refresh your demo web pages for me to see some traffic. If you don't, oh, I think that there is some traffic. And take a look here. We have this basically we have raw requests and responses. And so we can look for some sensitive content, and we see this authorization header, which is most likely like JWT token. Let's copy this token and go to our demo application. I will log in as Patrycja. Oh, and I see quite a few of you connected and registered. Thank you. So now I will go to developers tools in my Chrome browser, and I can see that yes, this application uses tokens, JWT tokens, as its authorization mechanism. So hijacking is simple. Once we have a token, we just need to replace it and refresh the page. And now I'm Fleckery. Congratulations, Fleckery, you've been hacked. And thank you for your cooperation. So that was the first demo. You could see like a series of misconfiguration could lead to hijacking and compromise of one of your accounts. How did it happen? First of all, a huge misconfiguration on Kubelet API, Open Kubelet API. Why did it happen? It happened because that's the default. If you use like self-managed Kubernetes, you must be very careful because the default is like to allow for anonymous authentication and authorization mode always allow. So those are the defaults. Obviously, you usually don't use self-managed Kubernetes, but just in case, it's worthwhile to know because otherwise you can end up with really insecure configuration. So that's Open Kubelet API. That's like number 9 in our OWASP Kubernetes top 10. Another problem we see in this demo is a series of misconfiguration on a pod container level. So basically, containers have a writable file system. If you have a writable file system, so even though you are not a root, you can still download a software and run it. So writable file systems are a big no usually. Another thing is run as root. Run as root, I could easily use APK and access any extra resources, for example, like mounts. That would be very dangerous. Another thing was that quite a few tools were available, so reverse shell was possible because NC netcat was installed. Another thing and another set of problems relate to networking. We have this unencrypted traffic. So even though application itself uses HTTPS, inside the cluster, the traffic was unencrypted. So that's a huge problem because together with this Open Kubelet API and me available to install TCP dump, I had access to all the data which were flowing in and out from this application. And another problem is also open egress to internet. So you need to make your system secure. If you don't need your applications to connect to internet, just install some network policies, firewalls, or any other security tools you can think of and are specific to your environment. So that was the first demo. And the second one is about remote code execution in one Kubernetes deployment. So even though imagine that you have closed and secured kubelet API, so we can't use this reverse shell on the kubelet level anymore. We can still, in some cases, access Kubernetes if we have an exploitable vulnerable application workload installed in our Kubernetes cluster. So here we have this RCE application, remote code execution application. That's a simple PHP script, which is obviously vulnerable and prone to remote code execution. this is like crafted application. However, such vulnerabilities happen in regular applications as well. In your applications you code, or for example, applications you install out of the box, for example, any CMS systems. There is a series of remote code execution vulnerabilities discovered in almost any CMS system you can imagine. So here, let's give it a try and see. That's a simple hello world application. Hello, Patrycja, but let's try with who am I? And we see that instead of Patrycja, now you see www data. www data suggests that there is Apache server running in the background and answering those requests, because that's like a default user for Apache HTTPD server. So here again, we can use our old trick with reverse shell, but instead of using kubelet API, we will inject this shell via this input field. So again, now I will disconnect here, and I need to listen with my ncat. I'm listening, and here I need to connect with reverse shell. So as far as I remember, that was this IP. Yes, we see that connection was received from Amazon AWS. So you see that I was telling true what I told you. My Kubernetes cluster is installed on EC2 instance. So we have a reverse shell here. Let's ls, who am I? www data, let's see mounts. Here you see that this pod is deployed in privileged mode. We could have access to the underlying host file system. However, we are not root, so it's not that simple. So another thing to do is to run some sort of port scanning to see what's available in the network. So here I will use NC again as a simple scanning tool, and I will scan a very specific pod. However, when you are a hacker, you most likely scan like a wide pool of IP addresses and wide range of ports. Here I'm have only limited time, so I prepared my commands tailored to my needs, basically. So let's try to scan what's available. We see that we have port 6379 open in this network. So 6379 it suggests Redis. Why Redis? That's a default Redis port. Redis uses this specific protocol to connect with its client. So it's not a REST-based API. That's a specific protocol to limit the traffic, basically, because JSON and REST API can be pretty verbose, and with Redis and replication and many clients connecting to Redis, we want to be Redis wants to be fast, and that's why it uses the specific protocol. So let's give it a try and see if we can connect to Redis. It has this echo command. Okay. So here we see that we can connect to Redis. It responded with Pong to our ping. So basically now we can see what's stored in Redis. However, here we have a problem with reverse shell because once we issued this command, we messed up our stream redirection. So basically I need to establish another reverse shell to reset the session. So again, submitting the same thing. Oops, sorry, not this one, this one. Let's take a look at what other commands are available. So basically here we can see all the keys. Let's give it a try. We see that we have like several keys available. And so now one kind request again for you, if you could log out and log in again. So here we can see that those looks like JWT tokens. And with JWT, we have some problems. JWT tokens do not expire. They expire, but they can't be invalidated. So if you log out from your application, there is no way to invalidate the token. So how applications are dealing with this problem? They basically have a store of invalidated tokens. And this one looks like such a store. So basically this Redis most likely is used as invalidated as a store for invalidated tokens. So that's why when you log out and log in again, your previous token will be invalidated and put into the store. Let me run this again, messed up.
Sorry, Patrycja, we we are running out of time, and we have to introduce our next speaker.
Okay. Do I have any more like 5 minutes to finish or no?
I think, Patrycja, we really impressed with your live hacking, and now we know exactly what we can expect from Kubernetes hijacking. Yeah. So thank you so much.
Just a short summary towards that it's only a top of a peak of an iceberg, and there is so much more when it comes to Kubernetes security. So you need to take a look and take into account the Swiss cheese security model. It's not only about a single vulnerability, it's usually a set of vulnerabilities. So you need to take care that each of your layer is protected just to avoid this simple connections like connecting those vulnerabilities to actually exploit and compromise your systems. And we need to remember that a fool with a tool is only a fool, so we need to work and improve ourselves to correctly secure our Kubernetes clusters. And it's all about continuous learning for all of us. So thank you.
Thank you, Patrycja. It was great and interesting, like hacking session.
Thank you so much, and thanks